Since 1995 till September 2018, he was a professor and head of the CSC department of NITTTR, a centrally funded institution of the Ministry of Human Resource Development, Government of India in Chennai. He has done an ME with the distinction from Indian Institute of Science, Bangalore, and a PhD from IIT Madras. He has obtained a blend of industrial research and teaching and training experiences of several years from India and abroad. As a software professional, he had developed over 150,000 lines of coding on Unix platform in India and abroad. In 1998, he was sponsored under World Bank to the Huddersfield University, UK on curriculum development in computer science discipline. In 2000, he was nominated to Manila, Philippines on computer applications in technical education and training under Colombo Plan. In 2017, he was nominated to Dhaka, Bangladesh on TVET CPSC programming on OBE. He has published and presented over 100 papers in national and international journals, conferences and seminars in India and in abroad, and also authored 2 editions of a book on computer graphics. He has visited over 1,000 technical institutions on various committees such as AICTE and in over 18 states of India. He was the chairman in implementing IT curriculum in Port Blair, Andamans. He has won several awards and accolades and distinctions from various organizations, including the Jawaharlal Nehru Memorial Award from the University of Madras. Ladies and gentlemen, today, Sir has consented this session amidst his busy schedule. We welcome you, Sir, on behalf of the Sai Ram institutions and the Department of CSC, Sai Ram Engineering College. Welcome, sir.
Yeah.
Over to you, sir.
Thank you. Thank you very much. And I hope, am I audible to all?
Yes, sir. You are audible, sir.
Okay. All right. Yeah, good morning to all the viewers. At the outset, I would like to acknowledge my sincere thanks to the organizers of this program, particularly to Professor Meena Kabilan, who has taken a very personal initiative in inviting me. And I'm very grateful to her for giving me an opportunity to share my experience with you. In fact, today's lecture on embedded OS for IoT from Unix to Android, I would be following the methodology suggested by best practices of Marzano. It is a part of outcome-based education. Some of you might have seen the new national education policy, which follows and advises to adapt to outcome-based education. In fact, there are clear mentions about best practices and learning outcome. In my presentation in the slides, if you note a term which will be appearing in the right-hand side top, which will just mention about a pedagogical component, which is called cognitive structure. You imagine that I am presenting this to students, for which please forgive me, because I hope all of you, most of you are teacher participants. But in outcome-based education, since it is a learner-centric approach, you imagine that you will be adapting the same technique to your students. But unfortunately, many of the pedagogical terms, like the cognitive structure, cannot be practiced in online mode. It requires face-to-face situation. So I will be just enacting to do that. This is only for your observation. Okay, let us start with the embedded OS, the main topic of today's interest. Just imagine in a real life situation that you have a web camera or a security camera fitted in front of your house. That is a device. You can call it a thing. What is IoT thing means? It is anything which is domestically useful, but it is attached with a sensor. Now, this device is connected to a video server, another device, and that is connected to the television in your house, which is another device. Now, this device to device, it should be compatible, and the data which is transmitted to, particularly to the television, must follow a standard or a protocol. And the video server a device which is again connected to your house Wi-Fi connection, which is again a modem, which follows a standard or a protocol, and that is also a device. Once this is connected to a modem, we are entering to the internet. That is called the Internet of Things come. This is just to give an idea. And in your house, you have connected this device. And in your mobile phone, you may be sitting anywhere else in some other city also. Through that mobile phone, you download an app which is supplied by the web camera group team, and you invoke. That is also a device, the mobile phone. Now, if you notice that all these things, these devices have got firmware, which is all compatible with device to device. But in your mobile phone, you should have, I will call it an operating system, but it is an interface. In the due course of time, you will understand that that is also an operating system, an embedded operating system that should understand the formats or standards or protocols and the devices. The device could be changed. Maybe your video server could be changed tomorrow, or a modem could be changed. Am I audible? All of you, I'm thinking that I'm. Let me go.
Sir, hello. Sir, cut out the hello, sir. PG, sir. Participants, please hold on. There are some issues. Participants, please hold on. Okay. Participants, there is a minor issue in please hold on, participants, for a minute. Sir will come. He has some network issues. He'll be back soon. Participants, please hold on for a minute.
Am I audible?
Yes, sir. Yes, sir. You are audible, sir. Yes, sir.
But I am host has disabled screen sharing. It says.
Okay, sir. 1 second, sir. 1 second. Madam, sir. இல்ல வரலையே ஸ்கிரீன் ஷேரிங் டிசேபிள்னு வருது பட் இதுல எந்தல வரலையே கோ ஹோஸ்ட்னு சார் வந்து ஷேரிங் ஸ்கிரீன் ஷேரிங் பண்ண முடியலன்றாரு சார் ஐ திங்க் யூ கேன் ஷேர் தி ஸ்கிரீன் நவ சார்
No, should I have to, because I am not seeing my video also. Right from the Sambanthan video, I am not.
Oh, you couldn't able. Oh, okay. Sir,
yeah, now I think
I think, yeah, sir. Okay, sir.
Yeah, but is it possible to put, hello?
Yes, sir. Sir, yes, sir.
Yeah, can you, my video is not appearing, but my picture or video.
Yes, sir.
A small box. Okay, anyway, can I go ahead?
Sir, you have to switch on your video, sir. Start video is there in your screen, no, sir. You have to switch on that video.
Switched on.
You have switched on, is it?
Switched on. Yeah. Mute and stop video is now coming, but my video is not visible. Stop video.
Start video is there.
Can you see me? No, you can't see, no, because I myself can't see.
Yes, sir. I couldn't able to see you, sir.
No,
but your voice is clear, and then your screen is shared. But
okay, then I will go ahead then.
Yes, sir. Okay, sir. Thank you, sir.
This one, stop. Okay. No, they cannot see. Yes. Okay, I'm sorry about this disturbance. I will.
Is your front camera on? Yes, sir. Okay, sir. Now it's clear, sir. We can able to view you, sir. Thank you.
Okay, now I'm sorry for the disturbance. Okay.
No issue.
Now we are going to say about 4 components and agenda. One is, we have seen in the example of the real world situation of using a web camera or a security camera, how the IoT is represented. You must understand there are certain issues in this setup. One is, are all connected by device. It's called connected with connected. And the device, whether it should be dependent on each other naturally, otherwise the device won't work. And it should be independent also, because it will create a standard. And this is a critical issue which we must analyze. I will be starting with the age-old operating system for a system called Unix, which the Linux is an offshoot of Unix, and you will understand Android is an offshoot from Linux. So it all started from the ancient operating system Unix, which is platform independence, device independence, and it has created a standard in the world. And the industrial standard came from Linux, and how the Linux has been used in Android. We will see about it. So we will be talking about independence, dependence of devices, platform independence, industrial standards, and open source system from the proprietary systems, like how Symbian operating system became open sources from the proprietary, and how Windows as a user friendliness component is used by all common man. So all are interdependent. We will be talking about these issues through outcome-based education. We will start with a real world situation. Several years back, this was set up in an industry with, I myself was involved in that. A computer, a super micro computer, which was VICAD, which is called, whether it is existing now, I do not know, which is a device, and it was running under a CPU called Motorola 68000 series. That is the chip which this super microcomputer was using. And this, again, another system called interactive IBM systems in those days. It came in the form of a desktop computer, which was running under a CPU, Intel. And I also used another system called AT&T Unix PC. This was developed by AT&T organization itself. Later, it was closed down. And this was running under a Zilog CPU. So you can see 3 different branded computer systems, desktop systems, and which was using 3 different branded processors. Now, I also used a workstation for display processing, which was AED graphics system, advanced electronic design. Later, this was changed to Silicon graphics, the famous system which was used in the production of Titanic movie, and several other accessories like the Hewlett Packard A0 plotter, Roland plotter, Calcom 64-button digitizer, a huge digitizer which has got its own staircase like that. And along with that, Suma Graphics, another tabletop digitizer. What I mean to say is they're all devices, they're all different branded systems. It is figuratively shown here, the YCAT Super Mini computer, which was adapting the Motorola CPU and the interactive IBM system with Intel and AT&T Unix with Zilog, and 3 more devices, and how these stuffs or things, I call it, should be connected. Now, this is an issue. Now, it's a real world problem. Now, before that, we will see about a regular computer lab, which is being adapted in your colleges. For example, you have a hub or a switch, which is connected with several systems, and most probably, these systems are all IBM compatible system with the CPUs, namely Intel, and the operating system residing in each system is Microsoft proprietary operating system. This is what the general case in any developed nations, particularly in India. Now, these are connected through a hub or a switch. You really call it a network? This is my question. Now, in reality, theoretically, this is a network, but the students present in that one, they are interested in the real world application. That is what outcome-based education insists upon. Now, they are interested in not with the textbook approach, but in reality, what is actually a network. This is what they are interested in, and this is a network. You can tell them that a YCAT Super Mini, which was running at a Motorola CPU, and an IBM interactive system running at Intel, etc., they are interconnected. They're all heterogeneous cluster, and this is really a network. Yes, the student will be motivated to look into that issue. Let us go to the issue. Now, the first one is hardware devices and software handshaking. This is what we faced as an issue in the example with a web camera. Now, let us look at a fundamental core logic. The fundamental core logic, which will remain maybe 30, 35, or 40 years in the computer science or information technology field, which will not change. But the contemporary core logic will be changing. Maybe 50% will be obsolete in 1 year time. This is what an anatomy is required. This is what even the modern national education policy says, that you have to retain the fundamental core logics and leave it rest to the students and teachers. Let us start to understand this a desktop system, which is a computer hardware is at the bottom and which is connected with assembler. Now, this is a concept a student should know. An assembler is manufactured by the manufacturer of the computer hardware. This is in general, but this has changed now. We will come to that in Android. But this assembler, we presume at the time being, so that you will understand what is device dependent and device independent. This assembler is manufactured, or in the sense that it is written in the form of coding by the particular hardware vendor who is residing at the bottom. Now, using this assembler, an interface is created so that it gives an interface between user-developed software in the top or a vendor-developed software. Now, user-developed software can directly deal with the assembler and go to the hardware aspect, or vendor-developed also could do that. Now, this you must understand thoroughly well so that you will understand the intricacies of Android mobile operating system. Now, let us go to this assembler level. If you go to the internet and find out in what language this operating system itself is written, you will get invariably it is with the assembler of the hardware system, so that a good handshaking is taking place. Now, let us deal with the fundamental concepts, so that using the contemporary core logic. For example, inside a floppy, what is there if you cut this a floppy, which is not available right now, but so that your students will understand the fundamental core logic, with the help of a contemporary core logic. Now, at the bottom, this is a plastic base in which iron oxide crystals of millions arranged in a discrete fashion. This is how in the hardware is arranged. Now, if you pause a small voltage here in any of the crystal, it will get charged. Now, when it is charged, you go to the a concept field. You assume that when it is charged, you call it 1. You go to the next oxide crystal, which is arranged in an this thing, discretely arranged. If it is not charged, you call it 0. So that it is ones and zeros are formed here. Now you can tell your students that if it is 1, you can call it bit. If it is 0, you can call it 0 as the value of the bit. Now you group these bits together. You can ask the student a question, how many bits make one byte? They will say immediately 8. You can ask why it should be 8, why not 7? Even 95% of the computers even today are running with 8 bits. But there are 5% of computers are running with 7 bits also. They should ask the question as why it should be, so that they will understand the international standard, which is ASCII. ASCII, the second letter says that it is an international standard. The standard says it should be 8. How it evolved, you can say that from nibble, which is 4, and then to 6, and then with the 7, with the sign, and then it became 8. And that is how it has evolved. This is using a contemporary core logic you are telling your students. Now with this, after grouping that, you again go to it, it will perform as 1 0 1 0 1 1 1 like that. You group it into bytes, and then again go to this ASCII, which is a fundamental core logic. Even though this was developed by IBM, which was originally a contemporary core logic, in due course of time, it has been established to a fundamental core logic. Now, the fundamental core logic alone should be retained in your syllabi. That is what the recent national education policy very clearly mentions that. It says all the contemporary core logics, it never uses the word contemporary or fundamental. That is the key learning area will be specified by government bodies like the UGC or AICTE or NBA or NAC. Now, after grouping that, you go to the fundamental ASCII, a standard, which will say that the first letter could be transformed into whatever you want to type it here. And now that is what the student here would like to know, how this is connected with the software. Now, using this principle, you can explain how it is done and where you have anatomically, you have separated into contemporary core logic and fundamental core logic. The student is interested in knowing the fundamental core logic alone. Now you go to another example with the CCL. Now the floppy has gone. Now an organic crystal oriented device, namely a CD, has come. Now instead of iron oxide crystal, the technology uses organic dye crystals, millions of them arranged in a discrete fashion. Now instead of charging an iron oxide crystal, because the material is different, they put laser and then burn the organic crystal. Once it is burned, you may call it 1. If it is not burned, it is 0. So only the technology differs, but the fundamental core logic remains the same. Again, group it, you get ones and zeros, converted it into a decimal number. Then because ASCII uses decimal number, the standard uses decimal number, you go and then again get the text, what was intended. Now the technology is again changed from the CD, now it has go to pen drive, flash memory, etc., which also uses different technology. For example, it uses 3 gates, and in the middle one, if the N channel, the negative channel, and using the float gate, when the gate is pressed, this will get charged. If it is charged, it is 1. If it is not charged, it is zeros. The rest of the principles is the same. Again, you group it, convert it to decimal, and then go to an international standard. You follow the same text is used. The technology may keep on changing. So you must tell your students that how the contemporary core logics keep on changing, whereas the fundamental core logics remains the same. Unless they are anatomically made different, your students cannot be in a position to understand the basic concepts. Now let us go back to our original device dependent. To understand that, you can give a 3 example to a set of students so that your students will get into a pedagogical component known as activation. You can form groups of students and tell them 3 different examples. For example, the first example uses a computer system called hardware Hewlett-Packard PC, which uses an Intel chipset and using its own assembler. An operating system has been developed. That operating system is CPM80. I'm not giving a fictitious example. It is a real world example. And the middle one, which uses TRS DOS Model 4, which is also an operating system, written in the assembler for Radio Shack TRS 80 model with the 8-bit Zilog 80 chipset. And you develop a software here, a user could develop or a vendor could develop using the facilities available in the interface or an operating system. The first one, let us assume somebody has developed a hospital management application. The last one, which is a famous Microsoft operating system, which is Windows XP. Now, the Windows XP itself was written in an assembler developed for IBM Pentium 4 in those days, which was using Intel 845E chipset. Now, for this particular CPU and the bus and the data width presumed in this Pentium 4, an operating system was developed, which was Windows XP. This was written in that assembler. Now, with this 3, your students will be very thorough that what is available, which is called applications. When you go to Android operating system, you'll be talking a lot of applications and also devices, which we started from the IoT example, which I mentioned in the very beginning. Now, when a user here, let us assume he has developed an application called banking software. Now, let us say this users want to take a copy of the banking application, which was developed under Microsoft, to this system, which was running under CPM operating system. Will it understand? This is a question you should pose to your students. Definitely not. Because the format, standard, devices, everything is different from this first example and the third example. Let us go to another representation. For example, the banking software, instead of reinventing the wheel, that is what even the present education policy says. You should do research, but not for reinventing the wheel. There should not be any repetition. So that education should be shared. That is the principle. Now, similar to the analogy which I'm talking here, the application of bank cannot be transported here. Hospital management developed in the first example cannot be ported. How to do it? In the recent advertisement made by the Mac operating system, which was again an Unix an offshoot, they have developed an interface routine in the operating system so that most of the software developed under Microsoft could be transported and back to the system, provided the interface routine is available. If it is not there, this is not possible. Now, what is device dependent? You must know. Now you think of Android. When applications become thousands upon thousands, like the one which is banking and the hospital management, there are thousands upon thousands. It is nearing to almost 800 million, or it's going to touch 1 billion software applications are going to be developed by the time 2024 or so. Then how the interface could be done? It is not possible with every individual one creating an interface routine. This is a major issue when you, before going to the Android for IoT, you must understand. Now let us go back to the real world problem once we talked about. Now the YCAT supercomputer, this setup, you know how it is feasible to make it. Now let us go to the real world problem is Motorola with the Intel, with Zilog, and the different types of machine with different types of devices. Devices must be compatible. Let us go to a socio-economic factor, because engineer and society is a graduate attribute your students must be developed with. Let us take any real world scenario. If you look at the development of computer manufacturers in the world and the CPU manufacturers in the world, you can say even now, even today, mostly it is by IBM compatible machines. Even HP, everything has become IBM compatible. And the CPU manufacturers are all Intel compatible. And also with the different devices like the National Semiconductor, Fairchild, Zilog, Xerox, etc., etc. Now, when you look at this market share, now economy also comes into picture. It is not only the computer science or an IT, it is economy will come, sociology will come, and humanities and sciences apart from the skills which they should develop, and also the attitude like engineer and society, ethics, etc. When you go to the operating system or the interface between this hardware and this one, we will see that Microsoft was in the occupying the major share. Now, this your student should understand before uh, he thinks about the Android, because it will go to a common man in the future. That is what it has come, and how Android has superseded this one before understanding the operating system. Now, the freedom is the first element when Android came. Now, let us again go back to the device dependent scenario. If you have the lowermost one is computer hardware dependent, which is proprietary branded system. And the assembler is invariably written in the for the hardware. Then and the operating system is invariably written using this assembler. This is what you have seen right from the CPM operating system to the Microsoft operating system. Now imagine that these two phases, the applications developed by users, the applications developed by millions and millions of vendors, which is available, they cannot reinvent the wheel for every hardware. This is what the Android has done. Now, why can't you separate these two phases? One is the computer hardware and the assembler, which is bundled with. You cannot separate them. It is not possible. Even you go and check up, it is not possible. And the operating system also go with it. Is it? Is it going with that? Then it will always be separated. Now you separate these two, the assembler and the computer hardware and all devices. You can call things also when it is attached with sensors or embedded system. Now you created a linking layer and all the applications developed by user or vendors, which will run in thousands, are separated. Then you need not bother reinvent the wheel for everything. You can separately develop. And this linking layer was Unix operating system. To understand the concept of Unix operating system, which was device independent and platform independent and also non-proprietary. It evolved a concept like open source. This happened in several years back, but that history we should not forget, because that is a fundamental core logic your students must understand. Now, when Unix was written, I told you that invariably an operating system is written in assembler. That means, was it written in assembler? Initially, yes, it was with the hardware. But later, it was separated into two pieces. One is called kernel, which is attached with the specific hardware, which was created with specific assembler. So the specific kernel was written in the specific assembler. Now the other portion, which is dealing with users, and now thousands upon thousands of applications, this was taken care, and that was called shell in the Unix. Now the shell, initially it was written in the assembler, later it was separated and written with a device independent uh, and non-proprietary open source international standard called C. C will never vanish from the world. Even with the artificial intelligence program are all being reconverted into C, because C is closer to machine. At the same time, it is device independent. Now let us see in our example, three example, Hewlett Packard with the Intel 8486. Now a device has been changed. Apple came, Motorola 68000 came, and another device came, IBM interactive system with the Intel. All these things, different assembles were developed, but did it change? The application areas need not change, because this was rewritten in C. This is a concept one should understand. Let us take a small C program. C will never vanish. Number one, main. It starts with main, a simple function name with a flower bracket. And the first one is defining the data type of a variable. I take a variable called printf. Now the variables data type is character, and I have to initialize the value printf equal to a. Will it work? Is it a correct program? This is called the constructivism, which is a pedagogical aspect yours to motivate your students so that they will understand and they will understand the concept. Now, this is a perfectly correct program because printf is not a keyword. If you look at the keyword, printf is not there. Something include is not there. Now, can you use include here? Yes, you might use it, but confuse later because printf has become a third-party vendor who has developed thousands upon thousands of applications. Now, when you understand the Android, you must understand the concept which evolved by Unix. This C program was an international standard, and C became a standard which never ever bothered about IO. IO means because IO is device dependent. Now, the printer, when you use it, you can initialize. Now, if you put another statement here, printf, bracket opens, then it will give conflict. It will give you are trying to use it for using a third-party developed software like the Android, which is you are downloading several thousands of applications. You are trying to use applications at the same time you are trying to use it as a variable for your program. It is conflict. You cannot use it. If you don't use it, you can very well use it as a variable. Now, this is a concept of what is device independence, what is standard your students should know. Now, we will go back to the system of inter-process communications before understanding the Android embedded operating system for IoT. You must understand this concept. Your students should understand. Now, before going to the application area, in which in the Unix system it used as the shell, which was rewritten in C language, and now we will think about the latest language when you are going to see about the Android operating system. I think the time is running out. I will skip many slides because around 10:30 I must finish off. The computer hardware with assembler it was originally a monolithic kernel which was used and the shell used C. Now let us see in the real world problems. Thousands of software could be written in such a setup. I will skip this because when efficiency matters, you must think of Android, because otherwise the user wants within no time his response from the internet. For example, if you're running a 150,000 lines of coding in any proprietary systems, like even Windows MS, Microsoft Windows operating system, it will take maybe 1 hour, even with the latest machine. But in Unix operating system, the program like C, Java, or Fortran, or COBOL are all part of, or the compilers are part of the system. Here also, because Linux is used in Android, this becomes part of the system. For example, in a mobile phone, you want to operate the flash camera, flash light, and that is a device inside the system. You cannot use an application using that provisions in the Android itself. You can do some programming to develop that. I will talk about it a little later. Now, this is one thing, efficiency matters. User friendliness also matters in the mobile phones. For example, Microsoft Windows point and click, a simple and straightforward operation, like the Word, database, etc., are straightforward, directly used for production. And similarly, the mobile phone also users wants is a common man who is using. So this concept also one should understand because the aspects have been taken care of in the Android. Now we will go to the freedom and user friendliness. We will go to the one more step which evolved, how Linux came and how Linux has become a part of the Android operating system for IoT. The hardware components and the assemblers, instead of a monolithic operating system kernel, which Unix used, it was segregated into memory, a device, a processor, a device, and a secondary storage outside the device could be used or inside itself, like your SIM card in your mobile phone or a memory chip in your mobile phone, which uses microkernels. Now, the microkernels must be attached with your command mode using what the principle used by Unix is the shell and the kernel. The same thing is used, but users are familiar with user-friendly interface because users are directly dealing not with these things, but with an interface. And so why can't we use Windows lookalike graphical user interface? This was thought about. And one side, Unix, which is called shell and the monolithic kernel. At the other side, we have microkernels for devices. Before understanding the Android, you must understand this concept, which is programs, which instead of shells, commands, programs, because in distribution, you're going to get apps, thousands and thousands more in their present day mobile phones. So inbuilt network capability should be there. Standard should be there. Stability of the development should be there. And also the user friendliness, and Linux was formed. A young fellow, and I'm sorry to use the word fellow, a 19-year-old college student called Linus Torvald developed from Unix operating system, which was developed by Professor Tannenbaum, nothing but Unix operating system. He wanted to create a device-independent graphical user interface and then develop an open source operating system, but which uses microkernels. And this, it became an international standard, which is called Linux. Using this name, this evolved. Why we have to look at this? Yes, we are going to look at Android, which is the base of the operating system, is Linux. Now let us say the Linux is born and the industrial standards have been kept. Let us quickly go through the advantages of Unix, Linux, so that you will understand better the Android operating system, embedded operating system for IoT. Background processing is native, which is not there in Windows operating system. Now, your students will be wondering why I say background processing is not there in Windows operating system. They might say that supposing I run an application software like a word processing, I minimize the word processing and then invoke a browser and go to the internet and started downloading something. The downloading something, I again minimize and maximize the word software, the word which I was using. Is it not background processing? The processes are running together. Then you must say, no, it is not background processing, which is natively understood by the Microsoft. Not that they don't know the technology, they very well know. But the thing is, it is commercial interest was there. That is why proprietary comes. It is not by using multi-threading, it is by using fibers. So to understand the concepts of a fundamental core logic, like the difference between fibers and micro-threading, your students should understand the concept of background processing, which is not natively not there in proprietary operating system. Now let us go to multi-user, then all other advantages, particularly the communications, because Unix was started by AT&T Bell Labs, which is nothing but telephone manufacturers. So now the mobile phone, all the commands, if you look at the internet command like slash, uh, colon and HTTP, and then colon, www, dot, etc., are all parts of Unix operating system. In fact, Unix and C languages used many characters which are compatible with ASCII characters. They were looking at one particular character which was not directly used by Unix operating system or the C language. Then they found one character like the at symbol. The at symbol became world famous. All your addresses in the internet came because of this invention from C and Unix. This at symbol is a part of ASCII, but it is not a part of Unix. It is not used by Unix and C. That is why in the internet address I became the dot man. Hello, madam, my voice.
Sir, it's okay, sir. It's
Now
okay,
is it
sir.
clear? Maybe
Yes,
I'm
sir.
going
Yes, sir.
near to my.
Yes, sir.
Okay,
Yes, sir.
but am I going in the right direction?
Correct, sir.
Okay,
Correct, sir.
okay, fine.
Thank you, sir.
Okay. I'm sorry about the technical problem. That is what I mentioned. The outcome-based education will be successful only into face-to-face. But of course, we'll be using online mode also. Okay, with that, so communication has become part and parcel. I want you to understand that the Unix is now in every hand in the form of mobile phone a common man is using, and Android depend on these concepts only. This is what I wanted to mention to you. So think of Android. Now we will go to demerits of Linux, and no longer with Linux, but with Unix, because Unix was unfriendly. because it is used by experts. Poor documentation, and it was unsupported and very tough to learn. This should not be there for a common man. This was taken care, and how the Android evolved using these demerits, we will see in a little while. Now, for branded support system, Linux has created a set of support. This is by vendors, even though it is open source. The support was given by various vendors like Red Hat, Slackware, Debian for different purposes. For example, if you want to use 1024 processes up to 1024 devices or things to say could be used. This is what the purpose of these branded system. Okay, I'll skip this because how these advantages of Unix and scalability, etc., which was there in Linux. That's why Linux became a part of the Android. The ICT to a common man. Now, in this our own real world problem, a mobile phone is attached. So we will understand the difference between a desktop system, which is loosely constrained, multifunction with different components. One could take it away, a component like the power system or a memory card or the basic unit or secondary storage, etc. They're all flexible, but loosely constrained. Each one has got a subsystem. When Unix was developed with this in mind, and Linux outshooted by with microkernel and then nanokernel. How the nanokernel comes, here it comes. When you look at the device, a mobile phone, which is single function, which is used by a common man, rigid and tightly constrained. You cannot take out a power unit here. If you want to take out, they will say you can simply throw it out, this entire mobile phone, and buy another mobile phone. Supposing even if your adapter card goes off, you simply, why do you change it? Throw it away and get another one. Take your SIM card and then put it in another embedded system. Here, since it is all tightly constrained, rigid and single function, it is called embedded. Now we have to think about the embedded operating system features. Embedded means a number of subsystems coexist, and the embedded system, a union of subsystems to do a specific task. That is what mobile phone is used. A desktop system is not, but a mobile phone. Now, 2.5 billion mobile phones is being used in 2000 itself. Now it may be several billion. Now, in 2000, handset makers were thinking of rigid because of the policy of the embedded Microsoft. It was used by Microsoft in the very beginning. It was costly because a royalty was paid to Microsoft. It was non-innovative because for every manufacturer, 3 people are involved. One is an embedded operating system, which was Microsoft, and the set manufacturer like Nokia or Scion, etc., and the service provider like BSNL or Airtel, etc. All 3 should have an understanding, but the royalty was going to the embedded operating system. Now, when we look at why Linux came from Linux, because of these characteristics. It is not open source because Linux is used for a tightly coupled device. For example, if you are using for Nokia, for an example, I'm telling, it cannot be an open source. That is why Linux became proprietary. It is a commercial version was developed by Monta Vista, a company. 34 million mobiles switched over to Linux from MS. The GUI was written in Eclipse. It was monolithic kernel. Let us go to one of the statements made by embedded system. Open standards is developed by Linux. We have seen from the Unix stability. For a long time, Unix was existing, and inbuilt network capabilities. As I was telling, communication is a part of Unix operating system. Now let us go to the specific characteristics of a mobile phone. It is small because it is tightly coupled. So needs hardware abstractions. This is the origin of IoT in the embedded operating system, Android. It should be ubiquitous because in mobile phone is used everywhere. That is what even things are also. Things means it is attached with sensors called devices, and it should be professionally used because it is several applications. It is connected. For example, I can connect my mobile phone with my laptop. what I did with my mobile phone, I operated my security camera, which was fitted in Chennai. Even you can go to Tiruchirappalli and you can start using your mobile phone and you can operate it. So it is connected, and have to be innovative because competition has been developed with the vendors who have developed with several devices and also applications. It should be platform independent, what we have seen from our exercises. Now the Symbion came into picture. This was exclusively for mobile phones. It was originally developed by Nokia, Sony, and Motorola, and also Siam. In 2008, this was Nokia announced a purchase of the entire Symbion and made it open source because in how it involved for mobile phone applications. You will be understanding how the explosion took place in application area. Basically, was written C++, which is an offshoot of C. You start from the device independence of C. Java, again an offshoot from C, not from C++. It is closer to C because it is machine, closer to machine. That is what Linux also is closer to machine, and how Android has used it as an embedded operating system. We will see in the next slide. Linux and Mac, this thing understood. This Symbion could understand. And Microsoft Visual Studio has been used for because VBNet and Perl operating systems. It could use it. And consortium of device descriptors were used by Symbion. Symbion was successful, but before it became a failure, I cannot use the word failure. Before Android came, Symbion was very successful because of these characteristics. Now let us go to smartphones. Our end we have come. We are reaching customer-driven economy. Now the world must support billions of common through mobile phones. Over 10 trillion pictures and photographs need to be digitized. There are more than 10 billion web searches are made per month. And man wants the response time, you and me, within 0.15 second, because otherwise streaming, they get frustrated. Applications needed are exploding to thousands upon thousands, and the birth of Android. Now, the Android started from Unix, I should say, principally Unix, because Linux started from, by Linus Torvald, from Unix. He used the form of microkernel, then Symbion used a nanokernel, and the hardware abstraction layer. We talked about the hardware abstraction, why from microkernel to nanokernel, originally from the kernel or the heterogeneous kernel, what we have seen. Now the Android runtime evolvement, and I talked about the interface between the Unix hardware and assembler with the application layer. And native libraries, which we have seen from the C program, thousands of programs like starting with printf was used by third-party vendor, and the Android framework is needed to connect it to the cloud environment, and the applications are drawn because it is thousands over thousands, and so an application layer is needed. Now let us go to the representation of a contemporary core logic. The Android also may not be there in future, something else could come. But the fundamental principle, so that your students will understand, remains same. The Linux kernel is in the part of the central system. Then you have its own devices like the camera, Bluetooth, and the media, which a mobile phone could use it. Then the hardware abstraction layer, which is modified by Linux using library in C and C++. Even today, it is with C and C++ only in the inner area. We will go to the Android middleware. The native libraries were still in C and C++, but there is a virtual machine is coming into picture, which is developed by Google, called Dalvik Virtual Machine. And the Dalvik Virtual Machine, which Android uses, and the Android is residing here with a framework in Java application interface. This application interface is written in Java. You can write in any language. Now, you can be familiar with many languages are coming, which you can write your own applications. Now, there are vendor-developed applications, what originally we saw in the development of Unix, like YouTube or a WhatsApp or a Twitter.
Sir. Yes, sir. Yes, sir. Yes, sir. It's connecting.
Am I audible?
Yes, sir. You are audible, sir. You can go ahead, sir, please.
No, I'm unable to share my screen.
Screen
Can you
share.
hear me?
Yes, sir. Yes, sir.
I am unable to share.
Yes, sir.
My...
We'll make you co-host in few seconds, sir. Sir, please try now, sir.
Yeah.
Okay, sir.
Is it coming?
Yes, sir. Yes,
okay.
sir. It's coming.
Now I will proceed. I'm sorry,
yes, sir.
because of the technical problem. I may
No,
take
no.
a few minutes to complete, but the very important one must understand. That is why. Now, okay, the application area, how these layers came into account, you have seen from this this picture. Now, what is Android? You will understand the entire picture from Unix to Linux to Symbian to Android. It is a Linux-based operating system for mobile phones, smartphones, and tablets. It was originally developed by Andy Rubins, purchased by Google in 2007 under Open Handset Alliance. The Source Mobile was application framework was developed in Java, which is an offshoot from C. And the Dalvik virtual machine was developed in C and C++. I will once again tell this point. It's very important. The virtual machine with Dalvik was developed by C, and the device independent originally with several, only 86 hardware. When Android software development kit was developed, now the application has shot up to around a billion. It was 750,000 applications came from the user developed or a vendor developed application in 2012, and it's over 10 billion downloads were made. Now, the features of Android is the main objective is applications done through application framework at the topmost level of the Unix, which we have seen, based on a Linux microkernel and runs with Linux modified by Google. Google modified Linux further, and the Dalvik virtual machine runs the application like shell in the Unix. 3D graphics was included. SQLite was used as a database. Connected like the Wi-Fi, Bluetooth, etc. Cloud to where the applications are residing through the cloud to device management. And more hardware applications which the Linux could understand is the touch screen, thermometer, pressure sensor, etc. Now let us do the development of the various versions. The names of deserts were given by Android because it will be used by a common man. And I was told that very recently they have removed this desert names. I do not know why. The first 1 and 1.1 came, no name was given in 2008. The major features were birth of Android. Alpha and beta versions came, embedded first time in the mobile phones. And now with the keyboard, etc., laptops. Cupcake, which was 1.5, 2009. On-screen keyboard. Third-party widgets. Donut, September 2009. CDMA technology was used. A variety of screen sizes and resolutions were put to quick search boxes were used. Eclat in 2009, Google Map came into navigation. The voice guidance in the map, which is now very famous throughout the world. 3D views also were developed. Frio, May 2010, small phones, tablets, and WhatsApp came. WhatsApp became a vendor-developed application, became world famous now in 2010. 2010 December, Gingerbread, 3D games came, and a sensor like thermometers were attached, pressure and all. USB device connections were done by the embedded operating system, which is Honeycomb in 2011, and Ice Cream in 2011, access to Linux by data users for data control. And this is very important development. One could directly use a Linux operating system. And Jelly Bean, multiple accounts, temperature control came, And in August 2018, Pi, which is came swiping between apps, you can do so. Because in like the example which we have seen in the vendor developed microsystem, I told you it is not natively available. Which is not natively available? Background processing was not natively available in Windows operating system. Instead of multi-threading, it uses fibers. This is an important concept your students should understand. Now, how it a summary we will make it. From policies and mechanism, which was originally adopted by the Unix operating system, it uses only mechanism. When we go to the Microsoft proprietary operating system, it uses policies like F1 key, F2 key, page up, page down, arrow keys and all, which are all not a part of
TGS, sir, can you able to hear me? TGS, sir, your voice, we could not able to hear your voice, sir. TGS, sir, can you hear me? Participants, hold on for a minute. Yeah, my voice is coming, yeah. Please hold on for a minute, participants. Sir will come back. Network issues are there. Please hold on for a minute. Attendance link would be posted soon. Okay, wait for it. Sir? Sir, can you hear me? TGS, sir, I think you are muted. Unmute yourself, sir. Yes,
yeah,
sir.
yeah,
Now,
I am unmuted.
Yes, sir. Now it's clear, sir. Your voice is clear, sir.
Okay, I'm sorry for the so much
No problem,
disturbances
sir.
so far.
No problem,
I
sir.
do
It
not know
always.
where exactly the problem is. Okay.
Okay.
Now, if anybody wants any questions, I can.
Yes, sir. I'll ask the participants, sir. Participants, sir has completed the session. Those who have any queries, either you can unmute yourself and ask the question, or you can post it in the chat box also. Participants, any queries? You can post it in the chat box, or you can unmute yourself and you can ask the question.
Yeah. Then chat box something. It's okay, sir. Something anyway.
Yes, sir. Chat box is enabled only. Okay, sir. Let me see. Any questions are there? It's enabled only, sir. So I told them, ma'am. Participants, any questions? The session is open to you now. Do you have any questions, sir? There is a question from the chat box, sir.
Yeah. See,
For IoT, I'll tell you the question, sir. No issues, sir. For IoT, what is the internet speed required to implement it?
Yeah, and this is a pure technical question. It depends upon the devices in which you are going to implement. So it depends upon the environment and devices. Conceptually, there is nothing like a minimum requirement at all. See, they have left it to the device vendors for the implementation, because you cannot control over these things. There is no standard like that there should be. For a particular setup, there is a particular requirement could be there. So there is no standard like there should be the speed in which you can implement like. Okay. There was a question from device independence is different from OS to OS. As I started with the proprietary operating system, Microsoft, even Microsoft embedded operating system was device dependent, whereas Unix started with device independence and Linux again became device independent. So it differs from OS to OS. But now the Android uses basically Linux. It is device independence. That is the main concept which we have done. Then
one more question, sir. How can antenna connected with IoT?
Yeah, it is another device. See, a device could be connected something like a video sharing device. An antenna could be connected to your television or any other devices, and that can be connected to a Wi-Fi so that it enters into internet. Once it is entered into internet, you can operate it from mobile phones. It has been done. It is done.
Sir, another question, sir.
Yeah.
Is there a difference between IoT and LoRaWAN?
I really have no idea about the LoRaWAN, but anyway, we can. My intention was to give a conceptual overview of how embedded operating system is used for IoT.
Okay, sir. Next question, sir. Is there any bandwidth range specified for IoT?
No. There is no minimum requirement and all, but depends upon the devices. See, our aim is to understand the concept of embedded operating system for IoT. If you are using a particular device in which the Linux could reside, then it will specify the minimum requirement, so that smartphones nowadays uses that. And if a particular device should have a handshake with minimum requirement, it should be all right. There is no specific standards.
Participants, do you have any questions? You can post in the chat box. Sir is ready to answer. Or you can unmute yourself and ask the question.
Sir,
What?
this is Dr. R. Sundarma from IIT College Road.
Yeah.
Shall we get your PPT before Friday so that we can answer for Friday session questions and quizzes?
Now it is up to the organizer. I will give my PPT to Dr. Meena Kapilan. So it is
Okay.
up to her to share.
Sir, it will be
Okay.
posted in the Google Classroom, sir. No issue, sir. We will take it up offline, sir. That's not an issue, sir.
Oh, okay, sir. Whether it will be posted before Friday or
We will do it, sir. We will do it.
okay, so then only we can go through and answer for your questions. Sir.
Yeah, yeah, sure, sure. It
Okay.
will be done. Okay.
Thank you, sir. Thank you. Sir.
Yeah.
Thank
Okay,
you, sir.
then, if there is no more question, I think only thank yous are coming. I take this opportunity to share, to acknowledge my thanks to the organizers of this program, particularly to Professor Meena Kabilan, who has given me an opportunity to share my experience with you. I once again would like to say that I'm sorry for the small interruptions in the audio system. Maybe I do not know where exactly it has happened. Thank you very much.
Sir,
Sir, one.
over to Meena Kabilan, madam. Sir,
Yeah,
please, sir.
yes.
1 second.
Sir, good morning, sir.
Good morning.
Thank you so much for your informative speech, sir. Even though in your health, I think I know many of the people is not aware of that. Last month only, sir suffered with the retina problem. So he is a very much in informative sessions in many of the areas. Anyhow, sir, thank you so much.
Thank you very much.
So, if it is possible, you have to send your PPT in our mail ID, sir.
Sure. I will send it to you.
Thank you, sir.
Thank you. I will
Thank you,
leave
sir.
now.
Yes, sir. Thank you, sir. Thanks a lot, sir. Thanks a lot, sir.
Thank you.
Participants, I think many of you have submitted the attendance. It has been posted in the Google Class. It has been posted in the chat. It has been posted in the chat window. So see to that you all are you all complete that. And then the next session starts by 11. Next session starts by 11:30. You can everyone can join by 11:20 a.m. You can all leave now. You can join by 11:20 a.m. Thank you.